Hope you guys are able to see the screen. You're able to see the one PowerPoint presentation, right?
Yes.
Okay. Yeah. So the thing is that first we will be in today's session, or probably first next two sessions, we'll be spending the time to understand the Oracle architecture. Once you understand the Oracle architecture, then it will be easy for us to do any other activity. So this will be the area where we'll spend more time on understanding the concept, the workflow of how the Oracle database is working. And after that, we'll be from the next session onwards, we'll be proceeding with the practical sessions like installation of the Oracle software, then maybe like the database creation, the user permission. So all the topics as we discussed earlier will be proceeding. Okay, so Oracle is a relational database management system, or RDBMS, which allows the simultaneous access to large amount of data stored information. This is a simple explanation, but day-to-day life we are dealing with a lot of databases, right? So somebody can give me an example of what are the databases that you are already working, or first thing why we need the database.
We need the database to store all the records from whatever is coming through the middleware interface, and to access it. There should be a back for the application to go bring some data, right? That's why we have a database.
Okay, why couldn't we? That's a valid answer. We want to store the data and we want to retrieve the data. The question here is that, we have the different other applications. Say, for example, why we need a Oracle database, or why we need a SQL Server database for that? Why couldn't we store the data in the applications like maybe an Excel, where in which we can store the data and we can retrieve the data? Why we are not using that Excel or any kind of application, that level applications to store the data? Why we are going with the Oracle or SQL Server or DB2 kind of applications?
Okay, can you hear me?
Yeah, I can hear you.
This is my immature answer probably. So I think in Excel, there's only so much you can store, right? You can store a lot, but in Oracle, you have flexibility of adding indexes to make your data retrieval sooner or whatever. Maybe that could be one reason, because it's easy to handle, or maybe you can design it this way.
Okay, that answer is absolutely correct. Anybody else got any answer? Okay. Say what you told is correct, Ahmed. Say in the case of the Oracle RDBMS or any other RDBMS, the data retrieval is very easy. For example, you have you categorize the data into different sections like tables, or different containers like tables, and on top of that you create something called an index, or maybe some other different objects like materialized view. Just one second, guys. Just one second. So the data retrieval is very easy with the case of, or with the help of the RDBMSs. And apart from that, there are a lot of things are there. For example, in an Excel sheet, or maybe any applications which is designed for a single user usage. For example, Excel is an application which is mainly designed for a single user. That means you can when a person is started accessing the one of the Excel sheet, it is very difficult for the other person to access and modify the data, especially when it is dealing with the simultaneous access, right? So the relational database management system have a lot of advantages are there, where in which first thing they are able to categorize the data, and then they are able to make a relationship with the data. For example, say you wanted to store the certain information, like say the employees official information and the employees the personal information. If you are storing that information on Excel, we may have to store it in the form of two sheets, or maybe two Excel files. Then if you want to retrieve something like say all the people who are belonging to the belonging to Bangalore area, it will be a kind of difficult process. You have to put first a filtering, and then based on the filtering, you are selecting data. Say now on that, maybe like you wanted to select the age group of say the age group of 30 to 40. On that, you wanted the people who are residing on say in flats. So when this kind of filtering is happening, then it's a tedious process to do that activity with Excel or any other kind of spreadsheet kind of applications. Fine. So when we are coming to the relation database management system, where in which the data is being divided into different compartments, and these compartments are interrelated. Okay, and so that compartments is also known as the tables, and the tables are being connected by using a relationship, and with that relationship we are able to retrieve the data, or you will be able to first insert the data very quickly, as well as the retrieval of the data is also very easy. So the data retrieval and the data manipulation, or the select statements, or the selection of the data, or the DML operations, or DML or DDL, that is data manipulation or data definition language, are much easier in the case of the RDBMSs. Second point, it allows the simultaneous access of the data, and each user's data is protected. Okay. For example, if you're looking at the Excel sheet, say assuming that in your organization your Excel sheet is being kept on a shared folder. So at that time, that Excel sheet can be protected by a password. But say Sharath is entering some record, Ahmed is entering some records, Vimal is entering some records. A person who accesses the say the Excel sheet with the password, he will be able to see the Vimal's data, he'll be able to see the Sharath's data, everyone's data will be there. There is no way that we can protect the data in terms of for each user, right? But in the case of the RDBMS, you are being protected with different layers. Like say you are given with a username and password, and then once the user is created, logs into the database, his tables or his data is protected from the other people unless he gives a permission. So the security is there. So mainly it allows the simultaneous access of the data. Second, its data protection is there. Third, we are able to maintain the relationship within data, and then the flexibility. You can create multiple databases, you can create this huge databases, and you can have the databases can be interrelated, and you can tune the databases by changing the different memory parameters, or so like that the database can be tuned and utilized in a different way. Okay, so that is the few major differences between the normal spreadsheet applications and that of the databases the relational database management systems. Is that clear?
Yes.
Any questions?
So, Vimal, so if I understood your, explanation right, on RDBMS, you have a flexibility of giving a user account and a DBO account or whatever read-only account. So the user account will still have access to all the information, but not access to the stuff which you have restricted in his account, but DBO may have full access to it. So it's like you're limiting.
That's good.
Okay, so in Excel, it's not going to be that way. I think in Excel, if you can open, you can view all of it.
Yep.
Okay.
Yep. Okay, and also that means Excel is lacking security. But if you're looking at the simultaneous access, say you cannot if one person is modifying, then the other person has to wait.
Right.
It's only accessing the single access only, right? So then say when you're modifying, whatever you're modifying, it's viewable by others. That means your action is not being protected, or your data, your transaction is not being protected from the other persons. But in the case of, and also say, for example, say assume a situation like you are you have saved an Excel sheet, or in that in terms of the Word also, whatever the normal applications are there, when which you store the data. Say you have a safe copy is there. Now you are trying to modify some data. Okay, say before modifying the data, you took a backup to your pen drive, right? Now you are modifying the data, assuming that after modification you have entered a lot of information, like 1 hour data you have entered. After entering that 1 hour data, you saved it, but unfortunately your system is crashed. Okay, so once your system is crashed, now the data what you are getting is that the data which you saved in the pen drive. That means the data with 1 hour like it don't have that last 1 hour data that you have inserted. That means whenever a crash has happened in the system, you may end up in a data loss. But in the case of the RDB database management systems, it has been designed in such a way that we will be able to minimize the impact of the data loss. I'm not telling that there will be zero data loss. It's not like that. There will be definitely data loss will be there, but there are different techniques has been implemented with the database, helping for reduction of the data loss. Is that clear?
So you mean it will be taking snapshots at given times so that something happens and you can go back to
yeah,
snapshots?
it is say one of the feature of a database or a transaction is that consistency. Okay, that means once the data is saved, then the data is permanently available for the user. The databases use certain architecture like the log file, where in which each transaction is being returned to a particular log file, and with the help of that log file, we will be able to retrieve or reapply the changes to the database once again and make the data available on the database. So there may be a situation where there will be a data loss will be there, but we can reduce that impact to a great extent.
Is it an archive log space or something?
Yeah, it is known as the redo log files in the case of the Oracle RDBMS. In the case of the DB2, it is known as the primary log files. In the case of the SQL Server, it is known as the transaction log files. So different RDBMSs give the different ways, different name to this technique. But endpoint, both everyone are doing the same thing only. Whatever the transaction that user is doing, the transaction is returned to the certain log file. With the help of the log file, the transaction can be retrieved and reapplied. Make sense?
Yes.
Okay. Now, like a database. So before coming to the database, there are certain other technologies or other terminology we have to know. So like say, in the case of the Excel or any other kind of application, we will be doing it on our laptop or PCs, everything. But when you're coming to the enterprise level applications, which have to store the bigger data, huge volume of the data, which should be allowing simultaneous read and access, each database will be installed on a server machine, a machine with higher configurations, with a high-end motherboard, high-end hardware, hard disk. So they are of server class machines. Okay, so that machines are known as the node, N-O-D-E, node in terms of the Oracle technology. Okay, so each node can have more than one databases running. Okay, so that means you can say you have a node with an operating system, say Linux is installed. There you can install the Oracle RDBMS software multiple locations. That means you can have one installation on say /Oradata, another installation on /Oradata1, another installation on Oradata2. Like that on the same server or the same node, you can have the multiple installations. Okay, and from each installation you can have multiple databases created. So that means in a single node you can have multiple databases available. Okay, and the database, the simple terminology, the database is the place where you store the data. Okay, when you're telling the storing of the database can be divided into two areas. One is at logical layer and the other one is at the physical layer. There are multiple classifications for the database or database server. One of the classifications is a database is divided into two components. One is a logical component and the other one is a physical component. Is that clear?
So,
Yeah, somebody was asking some question.
okay, so this is Ahmed. So, I mean, if I understood right, I mean, like you said, I mean, a physical Linux server can have, has a node, right? I mean, you can have multiple nodes in a physical server, right? You can set up that way. So each node can have one database instance running with multiple SIDs in it, like schema IDs, like multiple schemas or something, which corresponds to a different database for each one.
Yeah, say the question is that each server not consist of different nodes. So for example, the server on which the database is installed or database software installed is known as a node. In your question, say for example, with the concept of the virtualization, each server, each physical hardware, physical machine can be divided into different machines, different virtual machines in which we have the separate operating systems are installed.
Right.
So you can say that each node will be having its own operating system installed.
True.
And there you can have multiple installations of the Oracle RDBMS. For example, say in your laptop, you can install your Word software only one time, right? When you're next time when you're starting the installer, it will be telling that you want to uninstall or do you want to upgrade or that means it's going to work on the existing installation. But Oracle software, when it's being installed, it can be installed on two different places, entirely different path. That means at the end of that installation, you will be having your Oracle software installed on one location and another Oracle software is installed on the other location.
In the same VM.
Am I clear?
In the same VM, right?
Yeah. In the same VM, or in the case of VM or the physical machine, whatever it be.
Right. Okay.
And in an operating system, you can have multiple installations of Oracle software or Oracle RDBMS software. And each Oracle RDBMS software is capable of supporting more than one Oracle databases, or we can refer that for the time being, we will refer that Oracle 6 or SIDs. Is that clear?
Yeah, Deepak here. You said that we can have more than one a database in a node. So does the databases have any impact on the other databases? Means while accessing maybe the speed, not speed, the data access rate, anything with that performance?
Yeah. Definitely there will be, when you are having multiple databases running on that one and multiple applications are connecting to the databases, your say endpoint you are going to access the same physical storage.
Okay.
The data is stored on your hard disk. Okay. So different applications accessing the same hard disk. It need not be Oracle database itself. Say assume that you on the same database server you have some application server is there.
Okay.
So what happens is everyone are going to access the same hardware, right? So naturally the performance will be affected. But if you are looking at the enterprise level, we call a server or we call a node, which is being designed with that situation. I mean, predicting that situation. So that means you will not be having a server within which you have only 2 GB of RAM, only with 1 CPU of RAM, right? You will be having a good configuration, right? But still, if you are not utilizing that one properly, definitely it will be getting up. Definitely you will be having the performance impact.
Okay.
So, I mean, so in that case, what we can do is if you have a physical server which has a 32 processor and a 100 gig RAM, for instance, and if you got multiple instances of Oracle running, you can cap the memory per Oracle. Like you can say this Oracle instance is configured to have 5 core CPUs out of 32. So you can cap it. I mean, you can say this is your limit. Don't grow higher or lower. So that's what it's going to use. So even though there's other load coming to the system, it's not going to take the other processing capacity because it can only use 5 cores, right? Right, Vinod? You can design that way so you can cap it.
Yeah, that is possible. But the point here is that yes, we are telling that this is your limit. But the question here is that if you are not putting the limit, what happens is that I have seen several systems where in which 132 GB RAM system is supporting more than 12 databases. So what happens is that however you are telling that this is a cap that you are giving, but if you are not putting the or if you are not deciding the number of databases to be running on the server as a practical approach, then definitely your servers will be having a performance impact. That is not a database issue. That's nothing to do with the database, but that's a mistake with the design, right?
Sure.
Okay, Sharath, any questions?
I'm fine.
Yeah, good. Okay, so the Oracle RDBMS, you can say that Oracle database is divided into 2 areas. One is the logical layer and the physical layer. Okay, so what is the difference between the logical layer and the physical layer? The logical layer, as the name indicates, it's logical. That means analogy will be that. Say, for example, you are having you on your hard disk, like in your local hard disk, you saw a file called vimal.doc. Okay, so with that, what you will be able to tell? You can say that this is a file, a physical file is there, and there it must be containing some data. By seeing the size of that one, you can see that there is some data. But you will be able to physically tell that there is a file called Vimal is there, and you can tell up to that extent that this is a file which is created on Microsoft Word application, right? But unless will you be able to tell that what's the contents of that particular file without opening that file? It's not possible, right? If you wanted to see the contents of that one, you have to double click on that particular file, then the corresponding Word application will be opened and you will be seeing the contents from there. Am I correct?
Yes.
Just one second. Okay. So unless you open that application, you will not be able to see the contents of that one. The same way, for database to be working, you will be creating certain objects inside the database. For example, you will be creating a table, you will be creating a view, you will be creating a table space or indexes, whatever it be. But unless you open the database, unless you start accessing the database, you will not be able to say how many tables are there, how many users are there, how many indexes are there, how many records are there. But by using the operating system file, you will be able to see that this is a file created. Am I clear? So the physical structure of the database or physical layer of the database is the actual files which are visible by the operating system commands or operating system utilities, which will be containing the actual data. In the logical representation, the data is consist of the object which will via through which the application or the end user will be working with the data. Either it can be data selection or it can be data manipulation, and that manipulation or data selection eventually affect the data which is stored on the data file. Am I clear here?
Yeah, yes.
Okay. Okay, so on the physical structure of the database, an Oracle database consists of the following components. One or more control file. Second, 3 or more redo log files. N number of data files. At least we should be having 3 data files for mandatory. Okay, and then depend upon the certain configurations. Depends upon certain configuration. You must be getting something called the arclog files. Then you will be having something called the parameter file, and also you will be having something called the parameter file in the 2 formats. One is at text-based parameter file, and the other one is at the binary-based parameter file. Is that clear? So I repeat: the control file, the data file, redo log files, arclog files, and then the parameter file either in the text-based format or in the binary format. Fine. Now let's have a brief look on what all the things consist of. So first thing, we'll be taking the data file. So data file is the file which contains the information about or which contains the data. That means whenever you are inserting a data, okay, the data has to be stored permanently. For example, you work with a web application. You update everything, but finally when you are saving, what happens that the modified data is being written to the data file, or modified data is written to the file. The same way, because why that is doing, the data has to be, if the data has to be saved permanently, the data has to be stored in the form of files. Now, if you want to store some data on the database also, you have to store the data in the form of data files. So the data file, you can say that it is the container of the data. It is a place where the data is stored. Okay, and there can be n number of the data files are there. The maximum number of data files an Oracle database can support is being defined by a keyword called max data files. Okay, where this will be specific and how will be specific, we'll be taking up later. So for the time being, just understand that there is a limitation for the number of data files can be held, and there is a minimum number of data files should be available also. The minimum number of data files should be available is 3, and the maximum number is decided by the keyword called max data files, which is set at the control file, but we will be seeing later how to set in the control file. Is that clear?
Yes.
Okay. How about
so in case if you don't define it, that is also fine.
Which one?
In case if you don't define it, for instance, somewhere in some parameter file, if you don't define max data file, that is also fine.
Yeah, it is not also fine. What happens is that if you are not specific the max data file, then there is a default number. For example, a default number of 150 data files.
Okay.
That will be taken. So depending upon your application requirement, you may have to change it.
Okay.
But that was an older concept. But nowadays, like what the situation happen changes from Oracle 10 onwards, you can have the bigger table space files or bigger data files, where which it can store one single file itself can store petabytes of data. So that concept is being slightly changed with the higher versions, but still the maximum number of data files can be possible for a database is being defined by the being controlled by the parameter max data files.
Okay.
Make sense?
So during installation, you said, okay, I'll go with the default 150 data files, and later your app demanded more data, more tables, so you can go manually change even after it's been installed. So it can't at any time, right?
That's correct.
Okay.
Yeah. Now coming to the redo log files. So earlier I was telling about a situation where in which say you have saved data and you have a safe copy is there, but after that whatever you are modified, you saved it, but before you move it to your safe copy or pen drive, before that the data got corrupted or your file got deleted. That means you lost the data. Right? When you are restoring, you are going to restore with your 1 hour before data, right? Or the data which is there in their backup. So to avoid that, what the RDBMS are doing is that whenever you are modifying the data, Oracle is keeping that information, what the information about the data changes on the path on a special type of files known as redo log files. Okay, basically the mandate is that you should be having at least 2 redo log files, and once the redo log files in so each and every transaction will be logged into the redo log file. Okay, so for example, assume a situation where in which you have taken the backup of the database at 10 o'clock. Okay, and then from 10 o'clock, whatever you are modifying to the database is being recorded to the redo log files. Okay, and that's, let's take a situation where in which you lost the data around 1 o'clock. 1 o'clock you lost your data file. Okay, so as a DBA, what you can do is that you can restore the backup that you have taken at 10 o'clock and then tell Oracle to reapply all the changes from the log information which is captured. Am I clear here?
Yes.
Right. So the redo log file information can be reapplied to the backup and make that backup to proceed or roll forward in such a way that it will be in sync with the other data files. That way, there is no data loss we can guarantee. But of course, you should be having a different backup mechanism where in which you keep on taking the backup of your redo log files. If you don't take the backup of your redo log files, end of the day, and you have not taken a backup, and your system itself is crashing, so you will be end up in a situation where which you have the complete data losses there. But that is not being considered as a issue with the RDBMS, because RDBMS is already giving you an option. If we are not taking the backup of the database and the redo log files, then it's our mistake, right? So that should be taken, or that should be considered in that way.
So can these redo log files be applied to a different database on the other instance? I mean, when I say this, for instance, you have your middleware, right? I mean, and there's some disaster recovery or whatever. So the primary database which you are using for the application production has to move to a different disaster recovery environment with a different database. So in that time, I know there will be data loss for sure. Can these redo log files from this primary production can be applied to the DR database so that we don't lose any data?
Yeah, it is in that case we have to set up a database known as a standby database or the data guarded database, which is being actually taken from the backup of your primary database. It's not a new database.
Like a replication.
Okay, it's a dependent database where which from the dependent database, whatever the redo informations are generating, we can push the redo information to the dependent database or also known as a standby database, and then reapply that changes there. So that the standby database will be in sync with that of the primary database, and then will result in the case of a disaster or the primary database loss, we'll be able to, the application can be pointing to the database which is on the standby role, and then start working over there. Did I answer you, Ahmed?
Actually, you did. Okay, but is this a common practice, or because I mean, in our production, for instance, when there is a disaster recovery, we will be losing some data, and that's being communicated to the customer. I know there is there's like a replication of data, like GGL. I mean, Golden Gate testing, where what you do is you kind of make sure like the data is. I mean, that's fine. I mean, I think this is off the record, I guess, for this thing. But yeah, I mean, maybe I'll discuss with you offline. Will that be okay?
Yeah, I got your point. So the thing is that yes, Oracle is providing you different levels of the data protection. So for example, if you are having the data losses there whenever the primary is there, of course that will be having an SLA with the client, and if the client is agreeing. But there are different ways we can have zero data loss also. When you're having the disaster recovery mechanism, there is possible with the zero data loss.
It is possible without a data loss, right?
Yeah,
okay.
That's correct.
Okay, cool.
Okay. Probably when you're coming to the discussion of the data guard, the data guard classes, and then I can explain you more on how to set up the data guard with the zero data loss.
Okay. Okay.
Okay, now comes the major thing. So once we have the three major important components are there. One is that data files, other one is a redo log files, and along with that, before we be moving to the other one, there is a subcomponent of the redo log files that is known as the RK log files. Okay, why RK log files are required is that, say the redo log files are definite in number. For example, you created the redo log files with the 3, then that's all. That it will be creating only 3 redo log files only. It cannot create some redo log files dynamically. Am I clear here?
So the max is 3, right?
Yeah. It cannot go ahead and say you created with the 3 redo log files. That means that's the end. Oracle is supposed to create or use only the 3 redo log files unless you add one more redo log files manually. Okay. It cannot have for example, if it is a database files, it do have an option of the auto extend. It can grow, the data files can grow till there is a space at the OS level. But in the case of the redo log files, the design is not that way. Redo log files are being created with a definite number as well as a definite size. Am I clear? So, for example, you are creating the 3 redo log files, and each redo log file of say size of 500 MB. That means the total size of data can be stored on a redo log files is totally 500 into 3. That is 1500 MB of data can be stored on the redo log files. Now the question is that what if I want to store more data? Then the answer is that the redo log files are used or utilized sequentially. That means Oracle will be writing to the first redo log file. That is say from the scratch is starting. A database is created with a sequence number 1. A redo log file is created with a sequence number 1. So it will be using the sequence number 1, then 2, and then 3. Okay. Now, if it is more required, there is no fourth log file. So what it does is that it will come back and overwrite the first one. Okay. When it's overwriting, there is two options what Oracle got. Depending upon a configuration, Oracle can take a backup of the redo log files and then overwrite it. Okay. Other configurations that it just overwrite it without taking a backup. When we are taking a backup of the redo log files before overwriting, then that type of configuration is known as the arclog file. Or that kind of database is known as the archived log database, and that type of files which are created are known as the archived log files. Fine. So arclog files is another component of the Oracle's data physical layer. Any questions here? Okay, fine. The next one is the control file. So control file, you can see that this is the master or brain of this entire database. This guy contains the information about everything else with the database, including how many number of data files are there, what is the size of each data file, what are the number of, what is the location of these data files, and also what is the name of this database, whether the database in the arclog mode or non-arclog mode, whether how many number of redo log files are there, what is the size of the redo log files. All this information which is vital for the database is being stored on the control file. Okay, so you can say that without the control file, Oracle will not be able to find out the location of the data files and will not be able to start up the database. So that means for the startup of the database, control files are mandatory, and without the control file, your database will not be functional. Make sense?
So, I mean, going back to your original question, I mean, original explanation about redo files, I mean, there is a maximum of 3 redo files you can have in your database, and you define how.
It's not maximum. No, I didn't tell that it's a maximum of 3 redo log files. But what I'm going to say, you created with the 3, then Oracle will not be able to dynamically create the 4th one. Okay. It has to adjust with the 3 only.
Okay, so if we say it's 3, then it's going to go up to 3, and he's going to start rolling over. Right, I mean, he's going to start taking it. And if you tell the system to take a backup of that redo file before you overwrite the redo file, then he's going to take a backup and he's going to name that file as an archive log file.
That's correct.
Okay, and there's no limitation. It can keep growing, growing, and growing. You can have n number of files in archive log files.
That's correct.
Okay.
Unless the files is getting filled up.
And this archive log file gets stored into some directory location, and depending upon the disk space of that directory location, if it runs out of it, it's going to crash or whatever.
Yeah. Once the arclog files are filled, say for example you are storing to the /archive data. So that means that is the place where Oracle is going to write. So what happens is that if the DBA, once it is filling up, the DBA either has to be clearing that area or else adding more space, or else DBA should redirect the arclog writing to some other location. So if nothing is happening, then if something is happening, till something is happening, your database will be in a hung stage.
Oh, okay.
Okay. So this is the 3 types of files. You can see that the data files, control files, and redo log files. Okay, and we have mentioned the arclog files, parameter files, and the password file is outside the main square. The reason is that they are not the mandatory components. Okay, arclog files, parameter file, and the password file. Even if you lost also, it's not going to affect the functionality of your database. But other component, if anything is missing, then that is going to definitely affect the functionality of the database. Okay. Now coming to the logical layer. Okay. The component, the lowest component of the logical layer is a block, a database block. So you can say that in that picture itself, you can see that there are different blocks are there. The different blocks comes an extent, and different extents joins a segment, and different kinds of segments joins a database. Sorry, a table space, and different kinds of table space makes the database. Is that clear? So when you are storing some data to the database, it is going to be your entry point to storing the data will be a table. A table is consist of table is residing on a data file. So whatever you are inserting through a table is going to be eventually going to and write onto the data files only. Is that clear?
Yes.
And the different logical components of the database are tables, then indexes, views, stored procedure, database triggers, sequences, clusters, etc. And we will be learning about them in the short classes. Okay. Now, another representation in another representation, a database is divided into a different logical containers known as table space. So you can say that the this is just like as analogy to your bookshelf. So you have a bookshelf, and on the bookshelf you have the different racks are there. On the different racks you have the table, the books are there, and in each book you have the pages where the actual data is residing. The same way, your database is equal to your bookshelf. In that bookshelf, we are creating the different rack to make sure that that books are ordered correctly. So the same way, there is a component called table space, which is the container of which is a store place for the tables, and then each table space can contain the related applications, sorry, related objects. Okay, and each object will be having its own data type will be there, different columns will be there, and its own data will be there. Okay, but whenever you are inserting the data is eventually traveling from the tables to the corresponding table space, and finally it goes to the data file. So in nutshell, data for a database, table space is the point or the table is the point of entry, a point of interaction, but eventually the data is going and residing on the physical data files. Is that clear? Okay, and a table space, which is a container for the storage container for the tables, indexes, etc., consists of one or more data file. And it is when you are using more than one data file on a particular table space, the second, like the data files, you can spread across different storage area, so that it will be improving the performance of the database, or it will be improving the performance of the data access as well as the data retrieval.
Each table has its own table space.
Each table is not its own table space. Where table can be part of only one table space, exceptional to a certain situations like partitioning. Otherwise, a table will be always a part of a single table space only.
Okay.
But a single table space can have multiple tables associated with that.
Okay.
Give me a sec, I'll be back. Here we are getting a bigger picture where which we have a database is there. A database consists of the different table spaces. For example, system table space, accounting table space, and purchasing table space. And you can see that each table space has its own data file. And for example, the system data file is residing on the disk 3. The accounting table space got 2 data files which is running on the disk 4 and disk 5. And 3 data files basically. One is on disk 6. And purchasing table space consists of the table spaces on the disk 6 itself. Data files on the disk 6 itself. So it is not mandated that each data file should be containing on the same. All the data files of a single table space should be containing on the same location. It can be on the different location as well.
So what do we define in a table space? I mean, did we go through that?
Yeah, a table space is defined only because, say, eventually the data is residing on the entry point of the data to be is on the table, right? But we have to arrange the table in a proper order. So that means we need to have a container for the table space, and also the data is being written to the data file. That means the data file is something, a physical component, and the table is a logical component. So there should be somebody who will be linking between the logical and the physical components, and the table space is the one who does it. So the relationship is coming is that a data file cannot exist alone. A data file has to be created in association with a table space. Okay, so a table space should be having at least one data file. A data file should be associated with it's mandatory to associate with a particular table space, and it's also mandatory that the table will be residing on a table space. So table cannot alone exist. It has to be on a table space. So you can say that table space is the container for all these components. Is that clear?
Okay. Yeah. Thanks.
Okay, so when you are creating, what happens when you are creating a database, there are certain table space are created as a mandatory table space. For example, one of the table space is a system, and another table space is sysocs, and the third one is a temporary table space. Okay, so when you that means each table space will be at least created with the one data file. So that's the reason I told you the minimum required number of data files is 3. Okay, that means there are 3 mandatory table spaces that considering each mandatory table space will be containing at least one data file, we can say that there will be at least 3 data files in a database. And whenever a database is being created, Oracle creates a lot of information about the database itself into a set of built-in tables. Okay, so it can be built-in tables or built-in views or so this built-in objects contains the information about the database. So you can say that they are known as the metadata. Metadata stands for the information about the data or data about data. So when you create a table space, this metadata is being stored on a table space, and that table space is known as a system table space. So you can say that system table space is a mandatory table space which contains the metadata which contains information about the database itself. And this metadata gets updated whenever you are doing something with the database. For example, you are creating a new table. The corresponding data dictionary tables are getting updated. When you're dropping a table, when you're changing the size of a column, or whenever you're adding a column, whenever you're changing the data type of a column, whatever you're doing with the database, this information gets logged to the data dictionary tables. Is that fine? And the data files are the files which is created with the operating system and but with the specific commands which you shoot from the database. And certain files, certain operating system like Linux, Solaris, etc., will support the raw devices also. So that means you don't have to be the files need not be available on the operating system, but the data files can be on a unformatted hard disk or the raw device. But Oracle has stopped supporting for the raw devices. From Oracle 11G onwards, it is not directly supporting the raw devices. So people are moving away from the raw devices. Does it make sense?
Yes. Vimal, you had always told that a data file has to be inside a table space.
That's correct.
Is it, suppose if I just created data file, I have never associated it with a table space.
You cannot create it like that.
Okay.
You want to create a table space, the data file, the 2 commands are possible. One is that create table space, then data file, then the path of the data file and the size of the data file. First command. Second command, alter table space, add data file. At that time also, you are associating that data file with a particular table space.
Okay. Okay.
Right? There is no command called create data file, nothing is there, which is going to create a new data file.
Okay. Okay. And we can, a particular table space can be associated with multiple data files, but a data file is associated only with one table space.
That's correct.
Okay.
Okay, and the same holds good for the tables also. A table space can have multiple tables, but most of the cases, a table will be a part of only one table space. Only the exceptions are partition tables, where in which we can have the flexibility of creating each partition on a separate table spaces.
Okay.
Partition is a concept where in which a huge table is being divided into smaller chunks so that the data is being distributed on different table spaces, and on the different, so the different table spaces will have different data files, and the data files can be separated on different paths altogether. So that way you can utilize the power of data distribution and make the database perform better.
Okay.
Okay, the next one. So a database schema. A schema is a collection of the objects, and these objects are table, cluster, indexes, etc. Then another objects are view, and then the start procedure, then the database trigger, the sequence, etc. I'm just leaving this particular thing because I will be able to discuss in a better way in the coming classes. Okay. Now coming to the logical structure, let's see from a different angle. Okay. So in an Oracle database, the data is stored into a table space, and from the table space it is returned to the data file. So that means there is a lowest component via which the Oracle will be writing the data to the data file. So that lowest component, or the smallest unit of storage, is known as a database block. Okay, so a database block containing containing a header information which contains the information about the blocks itself as well as the data. That means a block contains a header portion and a body portion. The header portion contains information about that block, including the block number to which data file it is belonging, and also it contains information about the data which it's holding. Right? So when you create a database, you create a database with a particular block size. For example, you are creating with the 2K blocks, or you are creating with the 2, 4, 8, 16, etc. Right? Now, so the different boxes are available in Oracle database are 2 KB, 4 KB, 8 KB, 16 KB, and 32 KB. Okay, so that is a block size. So a block size. So like when the data is to be, like, say you created a table, you have a table space and you created a table on that one. That means the table has started occupying some space. So once it's growing, it is the actual growth is actual read and write is going to take place with the block size only. But when it's extending, or when that particular table is growing in size, it is not going to grow in, say, one database block size or 2 database blocks. Rather, it grows in a collection of blocks. Okay, that collection of blocks is known as the extents. That means whenever a table wants to extend, or whenever the table wants to grow, it extends in number of it extends in the number of 5 extents, 10 extents, extra, and each extent will be having a definite number of the blocks. Is that clear?
Yes.
Anyone, Sharath, Divakar, Ahmed, this is clear?
You were telling that, like the data blocks will be stored at, the data will be stored in the data file. So how is the data block and the OS level blocks, how are they related? Because
OS also got its own block size, right? For example, OS block size will be, or else you can say that Oracle block size will be a multiple of the OS block size. For example, whenever you're telling the database blocks, you're telling about 2 KB and or 8 KB or 32 KB. That means it is a size at which Oracle is going to write to the data file. Okay, then actually who's going to write to the file? It is the operating system is the one who is going to write the data to the data file. Then what happens that, for example, you have a 2 KB block size. That means the chunk size of the data it is written to the Oracle is written is with the 2 KB. That means say I have a block of 2 KB size, but internally that block 2 KB of block will be divided into 512 bytes of the OS. So OS block is 512. So OS is going to write in terms of its own block size only, right? So what happens is that when you are telling the Oracle block size of 2 KB of data is coming, then it will be divided by the OS block size, and it will be converted into that many units, and that units can be written serially or can be written parallelly also.
Okay, and is this controllable by a user, or it's at OS level, done at OS level, the parallel and serial?
No. Yeah, that is done at the OS level only. It's the DBA or the database doesn't have a control on that one.
Okay, got it. Yeah, thanks.
Okay, yeah. Now, now what happens? Let's say it will be considered of the segments. Now a number of segments joins or set of segments units becomes a number of extents joins together becomes a segment. So we have different types of segments are there. One is a table size, table extent, or sorry, table segment, or we have the index segments are there. So that is a different extent joins together becomes a segment. So if you are looking at the picture, you can see that we have blocks are there. A lot of blocks joins together become an extent. Number of extents together becomes a table or a segment. For every object which occurs to space, there is a corresponding segment is there. Many of times the segment, the name segment and the name like object in the objects like tables and indexes are interchangeably used, but they are not really interchangeably, should not be used. The segment is nothing but the collection of one or more extents. Is that clear?
Yes, sir.
Yeah. So there are two different types of data based on what type of different types of segments based on what type of data they are storing. For example, one is a data segment, another one is an index segment, and the third one is a rollback segment, and the fourth one is a temporary segment. So we have data segment is a data segment which contains the data within the database. Index segments consist of the information about the indexes, and then rollback segment is used for the undo of or like erasing of the data. And temporary segments are used whenever you are writing some temporary SQLs like a sorting of the data, like you are sorting as per the birth date, or you are sorting as per the first name. So at that time, Oracle is going to store this data temporarily for on a particular area that is known as a temporary table space. The segments of that particular table space is known as a temporary segments.
So I mean,
is that clear?
Yeah. So I mean, for instance, the data blocks or what do you call the extents or segments? They're pretty much used for storing the database, right? I mean, are they the same while retrieving some data from a database?
Yes. Okay. In the case of when you are retrieving the data, also we are retrieving the data in terms of the database blocks only. But what happens there internally, that blocks is being accessed, or you say that you wanted first 2 blocks of the data. So what happens there? Oracle gives a request to the OS, and OS go to the exact location of the physical location and retrieve the data and pass on out to the database query.
So if I say select star from this table, right? So I don't know how much data it's going to come. So how many blocks it's going to use, how many extents or how many segments he needs to do. He's going to do it automatically, right? It's not done by me. It's done by the Oracle itself.
Yeah, it is done with Oracle. Oracle uses that's the reason Oracle stores an information called the data dictionary, right? So when you are creating a table, what happens is it stores the all the information. That means a table is a part of a table space. A table space consists of a particular file. So Oracle keeps a track of all this information. For example, the starting point of this particular table is on file number 1. Okay, and then the last point at which grown is that it has taken up to 50 blocks of that one. So if you're telling that select start from the table, then Oracle knows that it has to go to the data file number 1 from the block number 50 to block number 100, select the data and give to the user. Is that clear?
Okay.
Okay. So Oracle stored all this very minute information also in the data dictionary, which will help Oracle to retrieve the data and manage the data very efficiently. Not to the matter that information is being this kind of data dictionary is available with all the kind of RDBMS vendors, but Oracle's architecture is a kind of very simple architecture, or when which we can tune many things with the Oracle architecture.
Okay.
Okay, extents are the building blocks of the segment, which is in turn consists of the data blocks, and extent is used to say the way that extent is used to that it is helping in the wastage of the storage. So when it creates, when it's required more space, it goes in that extent. And when it is when the data is released, for example, you have truncated a table or you have deleted some records, then Oracle will be able to shrink the unused space and give that back, the space back to the operating system. So efficient utilization of the space is being done with the help of the extents. When you create the table space, at that time you can say that the minimum number of extents to be allocated as well as the number of extents to be added each time, or else you can tell that you can specify that uniform growth, like say you wanted to whenever extension is required, you will be telling that okay, you utilize the extent by some 1 MB of size or 2 MB of size. That's also possible. So table space level, you can say that it grow up with the 5 extents of the 5 extents whenever it's growing, or else you can say that a uniform growth of say 1 MB, 2 MB, etc.
Can we say auto allocate and Oracle does that for us?
Yeah. Yes.
Okay.
Okay. So this we already discussed. Data blocks is all the lowest component, and they are the one which is physically stored on the disk. And the data blocks of normally it will be of for version Oracle 10G and Oracle 11G, the default is 8K blocks. But only one thing is that, one thing to be very careful, once you create a database with a particular block size, then you will not be able to change that blocks. If you want to change the block, then what happens is that you have to create a new database with the required block size, then export the data or collect the data from the original database and import or insert the data to the new database. Am I clear? For example, you have 8 KB blocks are now, and you are thinking that you need more amount of block size. At the time you want to say you wanted to go to 32K. At that time, what happens is that you have to create a new database with the 32 KB as the default block size, then take the data from the original database and import it to the new database.
So an extent is a group of data blocks, right?
That's correct.
So can you tweak the chain of extent to say, okay, I know, I mean, the data block size cannot be changed, but can it be fixed with increasing how many blocks should be included in extent? I mean, will that be like a workaround?
Yeah, but that is not a real workaround. Here the thing is that each, say, assuming a situation, say, you are having a 2 KB block. That means how much data you can store is 2 KB, right?
Right.
If you are creating an extent consist of, say, 12 blocks. So at that time, how much data you can retrieve at a particular point of, or how much data you can grow at a particular point of time? 12 into 2 KB. That is 24 KB is the size at which you can grow with a single extent, right? But if you're looking at, you are creating a table space with a block size of 32K. That means each single block itself is holding the data more than that of the 2 KB blocks. More than that of an extent of a 2 KB block. That way, if you want to store more amount of data, then definitely you should go with a higher block size.
Okay.
Okay. Now we are going to with another classification, where in which an Oracle, once you create an Oracle database, okay, you create a database with using the utility called DBC or somehow you created. Once the database is created, then the database is known as a database server. Okay, so database server consists of two parts basically. One is that instance, that is a memory part, and other one is that the physical part which you have already discussed. Okay, so the database server consists of the memory plus a set of background process which will help Oracle to manage the database efficiently. Second, it consists of the memory that is allocated. Okay, so an Oracle instance consists of the background process and the shared memory to access the information in the database. So the instance is made up of a set of the background process. Like it can be the background process are divided into mandatory background process and also non-mandatory background process. Just 1 second. the instance consists of the background process plus the memory. Now we'll see what are the mandatory background process are there, what is the memory structure is there. Okay. Now the Oracle memory structure consists of two major areas. One is at system global area and another one is at program global area or PGA. System global area stands for SGA and program global area stands for PGA. Okay. So system global area, like I say, assume that your database is having a lot of users are there. This memory area is available for each user. Sorry, available for all the users. That means it consists of certain areas where in which the data will be stored and getting manipulated. It consists of certain area where in which the source code of the different SQL commands we have executed, that source code will be there. So these are this area is given for everybody. But program global area or PGA is allocated for that particular process is available only for a user connection. Okay, so whenever a user is connected, a separate process is is being started, known as the server process. So the PGA is dedicated for each server process. That means the contents of that PGA is available only with that user only. It will not be accessible by the other users. Make sense? Any questions?
So the system, SGA, like it says system, it's used by system, and the program is used by your application, right? I mean, whatever your application is.
It is not exactly the application. The application itself may be using the SG also. But you can say that, so for example, in your application, say you have a dynamic queries running, and it is accepting the data from the user, say on the runtime. Also, you can say that bind variables. So this bind variables memory is allocated from the PGA.
Okay.
And also certain applications like say recovery manager, that is Oracle's backup and recovery mechanism. So that also uses the data for like this PGA for storing the memory, the data in the memory. So there are certain jobs explicitly use the PGA, but otherwise the system global area basically consists of common area which is available for all the users, like the buffer. Buffer is an area where the data is getting manipulated. Then the shared pool is an area where the SQL syntaxes are available.
Okay.
Fine. Okay. Now you can say that it shows you a small structure of the physical the Oracle instance. Okay. So you can say that in the Oracle instances consists of the memory. The left side, whatever you are seeing, is the physical files. So you can see that, or the physical structure. You can say that the background process like DB writer, log writer, and then the PMON, SMON, etc. different background process will work and writing and reading from the physical structure. And you can say that the SGA or the global area is being divided into, one is a database buffer cache, second is a redo log buffer, and the third one is the shared pool. Is that clear? At present, this picture maybe looks a bit complicated, but once you are understanding the different components of the instance, then this picture will become pretty simple.
So the PGA memory.
So let me.
The PGA memory structure is not used by Oracle instance, right? Am I right?
PGA memory area is used by not by the Oracle instance for management.
Okay.
It is used by the individual connections to the database. They are using it.
So it's called runtime, pretty much. I mean, for the application.
Yeah, that's yeah, yes, yeah. PGA is mainly used for the runtime access. Okay. Now let's have the more explanation of the system global area. So system global area is a shared memory region that the Oracle used to store the data and control the information about the Oracle instance. So SG is allocated when the instance starts and deallocated when the instance goes down. Each Oracle instance has its own SGA. So SG is consist of mainly the consist of one, the shared pool, second is a database log buffer, third one is a redo log buffer, and other structures like the lock and latch management, etc. Apart from that, there are two optional memory components are there. One is a large pool and another one is a Java pool. So that is also comes under SGA. So in SGA, you can say that the mandatory components are shared pool, database buffer cache, redo log buffer, and the memory area used for the locking mechanism. The optional components depends upon whether you are using Java pool or Java feature or not. There may be Java pool, and depends upon you are using certain other programs like Arman. You must be having a large pool also. Okay, that means as a DBA with later versions, you don't have to control, or you don't have to control. It's not like that you don't have control. You don't have to control the components of the SGA. Whatever the default way the Oracle is handling, it should be pretty sufficient for us. Any questions here? Okay. Now, to find out the how much memory is allocated for the SGA, you can issue the command once you connect to the database with the super user privilege. Just give the command show SGA. So you can see that in this example, total SGA is like almost 30 MB. On that one, something called variable size is there, database buffer is there, redo log buffer is there. And fixed size, there is something called fixed size also. That fixed size will not be changing or will be constant across the version of the database. Like say if it is 11G release 2, that is 11.2.0.1. For that particular release, that is the fixed area, which is used for a certain type of information or certain type of memory called the system memory, which it contains a certain type of tables which reads from the memory itself, or you can say memory structures or memory tables. Variable size is mainly used for the shared pool, and database buffers is the one which is used for the manipulation or the modification of the data. Redo log buffer is the area from where the data, whenever changes come updating, I told that the data will be returned to the redo log files. Before redo log files, it is being stored on the memory area called redo buffer, and from the redo buffer, it's being returned to the data to the redo log files. Any questions here? Hello, is everything clear?
Yes, please.
Yeah. Okay. Okay. Now, if you wanted to, there is a different ways of you can handle the SGA. Okay. In Oracle 10G onwards, you can say that SGA max size and SGA target size. So if you're telling that SGA target of SGA max size is 5 MB, and you are telling that SGA target size is 4 GB. So at that time, what happens is that the SGA can grow up to 4 GB automatically. Okay, and then if you want to go beyond that one, then you have to increase the max size by changing the instance level parameter entry. Okay, then the other parameter is that, so the memory, how much memory you are allocating for the SGA and PGA is being defined at the configuration parameter for the database. For every database, there is a configuration parameter is that either it can be a text-based parameter file or it can be a binary-based parameter file. So at that time, in that binary parameter files or in the parameter file, there is an entry called db underscore buffer underscore db underscore cache underscore size, which decides how much is the buffer area. Then there is a parameter called log underscore buffer, which decides how much is your redo log area. And then there is another parameter called shared pool size, which decides how much is your shared pool. And then it contains certain other things like large pools. Large pool size is defined by large underscore pool underscore size, and Java pool is decided by Java underscore pool underscore size. Okay, so SGA is dynamic and can be used by size by using the SGA max size, and the current size is being decided by SGA underscore target underscore size. So two parameters, SGA max size is the maximum size of the SGA can grow, or we can grow and without a reboot. Am I clear here?
Yes, please.
Okay, so SGA max size is 5 GB, means you can change the SGA up to 5 GB without a reboot. After that, if you want to increase, then you have to shut down the database. You have to change the size in the parameter file and then restart it. Right? On the live system, you can change it up to the SGA max size.
So I had a doubt here. Normally, how do we plan how much SGA does your application need, or the database needs? Like, how can you plan?
say there is no hard and fast rule for this activity. Okay, unless you understand your application, unless you understand how much data is being changed for every day, you will not be able to set that value accurately. But what you can do is that you can set up a static value and then keep on collecting the certain the advisors are there, like the DB cache advice is there, DB SG advisors are there. There are different types of advisors are there. With the help of that advisors, you will be able to reach to a particular value, or you can be able to reach an optimal value. So normally, what will that depends upon the size of the database also. For example, that is a wrong conception which many books tell to a DBA. Whenever you are going for a DBA book, so you will tell that say 50% of the memory, 50% of the physical memory is allocated to the database. But that is not the right tool. Suppose say if you have more than one database is there, then 50% of the total memory allocating to a particular database may not be right. So you have to start up with say I would say that is some amount of memory of the data, whatever the size you are thinking, and then you have to run the advisors like a DB cache advice size, or else you have to run the reports like AW reports, which tells you clearly whether your memory, the database is under allocated or not. The memory is under allocated or not, and based on that you can change the size.
Okay.
Okay, so in that SGA, the first command is that data buffer cache. So data buffer cache is the place where the data gets modified. Okay, so when the data gets modified, or the data the physical block is being read from the physical data file to the memory, and in that memory that gets modified. Once the block is being modified, then that block is known as the dirty block. Okay, dirty block in the sense that the contents of that block is modified. Now, once the data block is become a dirty block, then that block has to be, the contents of that block has to be returned to the data file. Okay, and that is being done by a kind of the different background processes are there. Like one of the background processes is DB writer, which writes the contents of the buffer to the corresponding data files. Is that clear?
Yes, sir.
Yeah. Now the redo log buffer. So whenever you are making some changes to the data database, that transaction gets recorded to redo log buffer, and from the redo log buffer, a different background process known as the log writer, one background process known as the log writer, which writes to a certain dedicated files known as the redo log files. Okay, once the redo log file is filled up, depending upon whether the database is in the arclog mode or non-arclog mode, it will be returned to the arclog files also by a process called arc process. Okay, now other one is a shared pool. Shared pool is the place where the actual SGA contains and it contains the SQLs which are being executed by the different users on the database. Okay, and also there are two things. One is at the SQL area, and the other one is at the library cache, where raw cache, where in which the data from the data dictionary table is being like Oracle keeps it's a copy of the data dictionary in the memory. That is known as the raw cache. So there are two things. One is a library cache which contains the SQL commands which are executed by the different users of the system, and then there is a raw cache which is being the copy of the data dictionary, which helps to Oracle to access the data dictionary in much efficient manner.
Vimal, in 11G there is a new feature where it stores all also the output of the SQLs. I didn't quite know that.
SQLs, output of the SQLs.
There's something like Flash or something. I just came across it, but I don't remember it exactly. If you can.
Flash. There is something called a flashback log area is there?
Not flashback. It's something like, you know, when a SQL is executed, it will also store the output in the shared pool or somewhere, and
whenever the same SQL is executed again by other user, it will directly get the output from the memory itself instead of doing a physical read.
That is not a new feature of Oracle 11. That is available with Oracle 10G also, wherein which or previous version of Oracle also. What happens is that the data in the shared pool and the buffer cache is being it can be reutilized. For example, you are giving select star from employee where employee ID equal to 100. So one time it is executed. Then the result is available on the memory itself, right? So at that time when you are running the second time this SQL statement, that is select star from employee where employee ID equal to 100. So at that time Oracle checks two things. One is that Oracle checks whether this SQL is already available on the memory area, that is a library cache. Once if it understands that it's available, then it's not going to check or reconvert the SQL. Then it checks whether the data is available on the memory, that is on the buffer cache. If it is available, and if Oracle is thinking that that is not being committed that is not being returned back to the data file. If it understands that the data in the memory is being already returned back to the data file, then it will not be taking that data. It will instead read directly from the disk itself.
Okay.
But if it is thinking that this is not committed or this is committed but is not being returned back to the data file, at that time it will be taken from the memory itself.
Okay. Yeah. Thank you so much.
So I think it's better that we'll stop here because it's going to be a longer session and too much of